Hey pre-calc students, welcome to today's lesson on how to apply the properties of logs when solving. So let's take a minute to just look at how we're going to strategize, okay? Whenever you approach a logarithmic equation, okay, you always want to check to see if you can condense the logs. So if you see multiple logs right away, you need to make sure you check for subtraction because that's a quotient, right? A division that converts to division. If you have addition, that converts to multiplication, a product. So that's first things first. No matter what, check each side, see if there's anything you can condense. Secondly, you're going to check to see if you have logs on both sides. Okay, so that's the key. If you have logs on both sides, you're going to see if you can use the uniqueness property. Now, the uniqueness property states that if you have the same log, same type of log. So I'm looking right here at this property. If you have the same type of log on both sides, then their arguments have to be equal. So essentially, if you have log base 3 of 4 equals log base 3 of 6x, then you can set the arguments of 4 and 6x equal to each other. So that's what that property states. Okay, well, what if you tried the uniqueness property and you don't have the same type of log on both sides? Then what do you do? If you can condense it down to one log and there's no other logs on the other side, then you just convert it to exponential. So I like to call it whoop whoop. So you convert it to exponential and then solve it. Now, for today, we're going to be giving exact and rounded answers. You may use a calculator, but one of the important things you guys have to know is that the more complicated that some of these equations get, it's possible that you might get some answers that don't actually work. So what we're going to do is we're going to check for extraneous solutions, okay? Extraneous solutions. Now, what you do with those is you substitute them into the variable of x, right? So if you're solving for an equation and the variable is x, once you find your answers, you're going to substitute them into any of the arguments where the x was. So in number 1, we have a couple of arguments, right? We have log base 7 of 4, log base 7 of x, log base 7 of 8, but the only one that has a variable is this one, the one in front, right? So if you get an answer of, let's say, 3, and you substitute it back in, that's okay, because the argument would be positive. What we're looking for is we want to make sure that none of the values that we get for our variable will make the argument negative, okay? No negative arguments. That's what we're looking for. If we get an answer like -3 and we plug it in here, we substitute it, then that would not work because we'd be taking log base 7 of -3, and that is not possible. So again, don't forget to check for extraneous solutions. All right, so as I look at number 1, I notice that I have multiple logs on the left and on the right. Well, according to the properties of logs, right, if I have subtraction of logs, I can change that into a quotient. So I can rewrite those. And just really quickly, guys, don't forget that coefficients are also exponents. So I'm going to go ahead and move that actually first. Anytime you see a coefficient in front of a log, that used to be an exponent. So let me just do that step first. And then I'll do the step of condensing. But some of you, you just have to find your own style of how you like to simplify these. I'm just going to do it step by step so I don't lose anyone. But you can condense them right away into, like this was a subtraction, so that's actually a quotient, right, between the x squared and the 4. And this is log base 7 of 8 over 2. Okay, so I'm going to go ahead and simplify 8 over 2. So 8 over 2 is actually 4, right? Now, according to my strategies, I'm supposed to see if it's possible maybe to use the uniqueness property. So the uniqueness property states that if you have the same log on both sides, a single log on the left, single log on the right, same type of log, right, log base 7, that their arguments have to be equal. So since I can apply the uniqueness property, I can finish solving this by doing that. setting their arguments equal to each other. Okay, so now I just use SADMAP to solve. So I'm going to multiply both sides by 4. I get x squared equals 16. Square root both sides. Don't forget this gives you two answers, positive and negative 4. Okay, but here's the thing. We're supposed to be checking for extraneous solutions. So if I substitute any of these numbers back into the original equation where the argument had a variable, so the only one, remember the only argument that had a variable was this first one. If I substitute positive 4 there, that would be okay because the full argument would be positive. But I can't substitute negative 4 there. So the negative 4 would be considered an extraneous solution. I cannot include it in my solution set. The only correct answer here is positive 4. And I'm just going to go ahead and label this as uniqueness property for those of you that think you might need to study this further. Remember, uniqueness property says if you have a log on both sides, same type of log, and they're equal, then their arguments have to be equal. Okay, so I'm just going to pay attention really quick for the extraneous solution part. This argument is the only one that has a variable in it, so that's where I'm going to do my substitution. If I get more than one answer, I need to make sure I plug them in, substitute them in, and make sure that this whole argument is not negative, okay? But that's where you're going to be substituting your solution if you get one or multiple. Okay, so I notice right away that I have addition here of two logs. According to the properties of logs, I can rewrite addition as multiplication. So I'm going to go ahead and put the 4 in front, but really it doesn't matter. You can just do quantity 3 plus x squared times 4. But I want you guys to realize that the 4 is going to have to be multiplied to both the 3 and the plus x. That's a binomial, right? It's a binomial. It's got two terms. So when you multiply with 4, you got to multiply the 4 with both of them. Okay, so I've got 12 plus 4x squared. If I simplify that, if I multiply these, now I can use the uniqueness property because I have the same type of log on both sides. So what I essentially can do is just set the arguments equal to each other. All right, guys, now what I notice about this is it's like the other one. I should have been more specific in the previous one, I'm sorry. When you have a quadratic with no linear term, okay, if you don't have a linear term where it's just something with x to the first power, then you can use SADMAP to solve, which is inverse order of operations. If you did have a linear term, then you would have to try using factoring or quadratic formula, and we will do some of those. But since this does not have anything with x to the first power, I'm going to do SADMAP, so I'm going to subtract 12, divide by 4, and then square root. So remember, you're trying to isolate the variable. So I've got two solutions here, plus or minus 3. I need to make sure that both of them work, and if they don't, cross out the one that is extraneous. Now remember, in the original problem, one of the arguments had an x squared, right? It was the natural log of 3 plus x squared. So I'm going to look in the original equation, right? I had ln of 3 plus x squared. If I substitute positive 3, I'd get 3 squared plus 3. That's not going to come out negative. What if I substitute negative 3? Would that come out negative? Nope, because negative times negative is positive, and you'd actually get the same answer for both positive 3 and negative 3. So then they are both solutions. Okay, but remember, you're plugging it, you're substituting substitute answers to the original arguments. Any of the original arguments that had a variable of, or had any type of variable. Remember, this is a video, so you can pause, rewind, stop, do what you got to do so that you understand the lesson. Okay, for the next one, I see that I have addition of two logs. That can be rewritten as a product. I can condense those. I can use the uniqueness property. They're both natural logs, right, ln. And if, according to the uniqueness property, if the logs on both sides are the same type and they're equal, that means their arguments are equal to each other too. Now take a look at what's going to happen here. So when I distribute the x, right, to the x plus 5, to that binomial, I get x squared plus 5x equals 8x minus 2. So because this has a linear term, you know, a linear term, remember, is anything with x to the first power, then my choices are to try to factor it, and if I can't, I have to use quadratic formula. So no matter what, for these, you want to make sure you have all the terms on the same side. That wasn't the case with the ones that didn't have the linear term. So in examples 1 and 2, they didn't have a linear term, so I didn't have to set them equal to 0. My goal was just to isolate the variable. Here, when you have a quadratic and a linear term, you do want to set them equal to 0. So I'm going to go ahead and subtract the 8x, subtract the 8x. And you can do this one step at a time, or you could do it multiple steps at a time. All right, so we get x squared minus 3x plus 2 equals 0. This can be factored. So since it can be factored, I'm going to go ahead and factor it. But again, if you would prefer to use the quadratic formula, you can. Just remember that factoring is a lot faster than quadratic formula, so please practice your factoring and do factoring whenever possible. So this factors to x minus 1 and x minus 2. You get two solutions. Now, I'm just going to really quickly go back to the original problem, okay? So I have to check these. If I substitute positive 1 into any of these, look at, we have 3 arguments with variables, right? So I need to substitute it there. If I substitute 1 into any of these, would it give me a negative answer? Nope, because here it would be 1. 1 plus 5 is 6. 8 times 1 is 8 minus 2 is 6. So none of those would give me a negative. Same if I substitute 2. I'd get natural log of 2, natural log of 7, right? 2 plus 7, and natural log of 14 from 8 times 2 is 16 minus 2. So your goal is to make sure that you don't have any answers that when you substitute them give you a negative argument. So in this case, they both work. Now, if neither of them work, then you would say no solution, okay? So if they're both extraneous, you get 2 answers, they're both extraneous, or even if you just get 1 answer and it's extraneous, you can say no solution. Okay, so I'm going to follow the same rules here. This is addition that can be rewritten as a product, multiplication. Now notice I cannot use the uniqueness property because I do not have the same log on both sides. The uniqueness property states that if you have the same type of log on both sides, then their arguments can be set equal to each other. So since I have a single log, I can use the whoop whoop, whoop whoop, convert it. Convert to exponential. So I'm going to have 4 cubed equals x times x minus 2. I'm going to go ahead and simplify both sides. And then I notice that I have a quadratic and a linear term. So these you do want to set equal to 0 and try to factor or use the quadratic formula. So pause the video, take a minute, and see if this could be factored. If it is, factor it. So I'm looking for numbers that multiply to negative 64 but add to negative 2. Okay, you should have noticed that unfortunately, because of the discriminant, b squared minus 4ac, remember that's how we check to see if something can be factored, you get 260. That is not a perfect square. Okay, remember if it's not a perfect square, then we can't factor it. But if we would have gotten something like 100 or 144, right, then we could have factored it. So I'm going to do x equals the opposite of b plus or minus the square root of b squared minus 4ac, which I already did, all over 2a. I'm going to simplify the root. So the biggest perfect square that goes into 260 is 4. So it's 4 times 65, which simplifies to 2 root 65. Okay, then we reduce. So you can reduce these guys. I know it's been a while, right, since we've done stuff like this. Okay, so we've got two answers here. We've got 1 plus root 6, 1 plus, root 65, and 1 minus square root of 65. Take a minute and put those in your calculator and kind of round them to a decimal, okay? So 1 plus square root of 65. I'm going to do it right now. 1 plus square root of 65 is about 9.062, and they want 3 numbers behind the decimal. Now I'm going to do 1 minus square root of 65. That's negative 7.062. Which of those, if any, when they're substituted back into the original problem, would create a negative argument? Well, look, this guy had a variable, so did this one, right? One of the answers was negative 7.062. If I substitute negative 7.062 into number 4, that's not going to work. Same if I substitute it here. So the negative, no bueno. We don't want it. Now remember, the directions did ask us for exact and simplified answers. So your exact answer would be the one without the decimal. Your rounded answer would be the 9.062. I like to use the squiggly equal sign for those. Now, we know that it's hard to keep track of all the homework and all of your classes, and some days are heavier than others in terms of workload. But when it comes to math, you got to remember, if you don't practice, it doesn't sink in. So you have to make sure you're practicing your stuff. Okay, remember that addition converts to a product. You can simplify this now or you can do it later. In the previous problem, I did it later, but I think I'm going to do it first, just to show you guys that it's really up to you when you simplify. But either way, notice that I can't use the uniqueness property. I'm going to have to convert here. When you're left with a single log, you're going to convert to exponential form. So I'm going to have e to the third power equals 2x squared minus 9x. Now this is interesting because we have e to the third power. Now if you actually type that into your calculator, remember you can push second and then the natural log, ln. E to the third power is about 20.086, okay? So because this is a quadratic and linear sorry, it has quadratic and linear terms, you want to set it equal to 0. So you want to have all your terms on both sides, or sorry, on one side. Oh my goodness, my brain's not functioning anymore. Remember, if you have a quadratic and a linear term, you want to write it so that all the terms are on one side. It might not look like it, but e to the third is a constant term. That's what the C stands for. E to the third is a decimal. It's 20.086. Okay, well, this is not factorable, not when you've got e to the third and then the rest are just normal coefficients. So what we're going to do is we're going to do the quadratic formula. So I'm going to do the discriminant off to the side, b squared minus 4a, and I'm actually going to leave e cubed as e for now. It'll make your life easier, kids. So 81, negative 4 times 2 is negative 8 times the negative 1 that's in front of the e. That would be positive 8e cubed. Okay. Remember, the coefficient for e was negative 1. So again, notice I left the e as is, right? I left the e as is. You don't want to change it to a decimal quite yet, because if you change it to a decimal now, then your final answer will definitely be off. You don't want to round your answer yet. You want to round at the very, very end. So the quadratic formula is x equals opposite of b plus or minus the square root of your discriminant. So notice I did not put e in my calculator yet. I left it as e all over 2 times a, which would be 2 times 2. And now you're going to just take some time carefully putting in your calculator. 9 plus the square root of 81 plus 8e cubed over 4. Make sure that all of this is in the numerator, okay? Numerator and denominator. Then you can get your decimal value, because we ultimately need to check to make sure that both of these are true solutions. All right, pause the video and practice putting these in your calculator. If you try it and you can't get the answers that I do, you need to make sure you reach out to your teacher, to me or to Ms. Vaca, so that we can show you how to put it in your calculator, okay? But it's important for you to know how to put this in a calculator. What I use is I use second ABC. So I'm going to show you really quick. Not second ABC, sorry. Alpha y equals, oh my goodness. Second ABC is for a whole nother calculator. I'm going to use a graphing calculator for this. So I do alpha y equals, so alpha y equals, enter. And then I do 9 plus, then I do the square root. Then what is it? 81 plus 8e cubed. So that's second natural log. And then come down and put the 4. Okay, so about 6.137. So that I can avoid typing all of that over again, I'm going to push second enter. Second enter allows you to retype, like the calculator retypes everything you previously typed. So I'm going to go ahead and just change, whoopsies, change the plus sign to a minus. Okay. So practice putting that in your calculator. Pause the video if you need to. We've got two answers. We've got 6.137 and negative 1.637. Substitute them back into the original problem and make sure that none of those give you a negative argument. Now, since one of the logs was natural log of x, and you found that x is negative 1.637, then that can't be an answer. Okay, so the one with the positive gave us approximately, so these would be our exact answers, guys. Sorry, my computer's a little laggy. Okay, so our exact answers would be the 9 plus square root of 81 plus 8 root 80 to the third power over 4. And then the same thing but with a subtraction. The rounded or approximate answers would be x is approximately 6.137 and approximately negative 1.637. Now remember, you got to substitute them back in. If you do, you'll notice that that one can't be the answer because it would make the argument negative. I always tell you guys to be careful with math classes in general because if you're just learning things for the test, it'll ultimately catch up to you. You really got to try to learn them for long-term use because notice this chapter is different than Unit 2, but in the same way, it uses the same concepts as Unit 2. And Unit 2 is when we were looking at quadratics and how to solve them, quadratic formula, etc. Okay, so let's take a look at this next one. My computer is a little freaking out that I have way too much inking. Okay, so I'm going to delete it all. All right, so I have natural log of x times x plus 3. Remember, addition can be written as a product. I'm going to simplify that. I get x squared plus 3x. Then I'm going to go ahead and convert because I only have one log. So I get e to the first power equals x squared plus 3x. Remember, if your quadratic has a linear term, you want to set it equal to 0. So I'm going to move the e to the other side, but not with magic. I'm going to move it by subtracting it. So if you have a quadratic with where one of the terms, right, is e, you're going to, it is a number, right? So e, if you put it in your calculator, e to the first power. So if you push on your calculator second ln and raise it to the first power or second division sign, it's 2.7182818, blah, 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 right? So this can't be factored, but we're going to just leave it as e, but just know it is a decimal. It's 2.718. We rounded it to 2.72 when we were doing our graphs. All right, I'm going to do the discriminant off to the side. B squared minus 4ac. Remember, the e has a negative 1 in front. So how do I simplify that? 3 squared is 9. Negative 4 times 1 times negative 1 for the e, right, is going to be positive 4 and e. So x equals the opposite of b plus or minus the square root of the discriminant all over 2a. Okay, moment of truth. Practice putting these in your calculator. Round them. And see if any of them will be extraneous. Okay, so pause the video. So remember, these are exact answers. These are exact answers. That's how we're going to want you guys to write your answers, with e, no decimals, okay? But then you're going to convert them. So pause the video. Push play when you're done typing it into your calculator. All right, hopefully you didn't cheat, but I got two answers, and when I plug them back into the original problem, the one that isn't going to work is the negative, because the natural log of x, if I substitute the negative 3.729 in for x, would make that argument negative. Now be careful, because not every single negative solution means that it's extraneous, right? You've got to plug it back into the original problem to decide, okay? And the rule is, it doesn't have to make all the arguments negative. If it just makes even one of the arguments negative, it's a no-go, okay? All right, guys, as always, if you have any questions at all, feel free to reach out to us. We'll be more than happy to help you. Have a great day.